Polygons. Objectives: 1. Define, identify, and illustrate different kinds of polygons according to the number of sides. 2. Identify the parts of irregular polygons, interior, exterior, and the points on the polygon itself. 3. Differentiate convex from non-convex polygons. 4. Determine the sum of the measures of the interior angles of a polygon. 5. Determine the sum of the measures of the exterior angles of a polygon. A polygon is a closed plane figure formed by fitting together segments end to end with each segment intersecting exactly two others. Polygon. Because it has straight sides. Not a polygon. Because it has a curve. Not a polygon. Because it is open. Meaning it is not closed. Polygon. Comes from Greek. Poly. Means many. And gon. Means angle. Each line segment is called a side of the polygon, and each endpoint where the sides meet is called the vertex of the polygon. Note that consecutive sides cannot be collinear, and no more than two sides can meet at any one vertex. Polygon parts. Side, one of the line segments that make up the polygon. Vertex, point where two sides meet. Two or more of these points are called vertices. Diagonal, a line connecting two vertices that isn't a side. Interior angle, angle formed by two adjacent sides inside the polygon. Exterior angle, angle formed by two adjacent sides outside the polygon. A diagonal of a polygon is a line segment that connects two non-consecutive vertices. A polygon also separates the points of the plane into three sets: the interior of the polygon, exterior of the polygon, and points on the polygon itself. Polygon names. Generally accepted names. Sides name n-gon 3 triangle 4 quadrilateral 5 pentagon 6 hexagon 7 heptagon 8 octagon 10 decagon 12 dodecagon. Names for other polygons have been proposed. Sides name 9 nonagon, enneagon 11 undecagon, hendecagon 13 tridecagon, triskedecagon 14 tetradecagon, tetrakedecagon 15 pentadecagon, pentakedecagon 16 hexadecagon, hexakedecagon 17 heptadecagon, heptakedecagon 18 octadecagon, octakedecagon 19 enneadecagon, enneakedecagon 20 icosagon 30 triacontagon 40 tetracontagon 50 pentacontagon 60 hexacontagon 70 heptacontagon 80 octacontagon 90 enneacontagon 100 hectagon, hecatontagon 1000 chiliagon 10,000 myriagon. To construct a name, combine the prefix plus suffix sides prefix 20 icosachi, 30 triacontachi, 40 tetracontachi, 50 pentacontachi, 60 hexacontachi, 70 heptacontachi, 80 octacontachi, 90 enneacontachi, plus side suffix plus 1, henagon plus 2, degon plus 3, trigon plus 4, tetragon plus 5, pentagon plus 6, hexagon plus 7, heptagon plus 8, octagon plus 9, enneagon examples, 46-sided polygon, tetrachondecahexagon 28-sided polygon, icosahexagon. However, many people use the form n-gon, as in 46-gon, or 28-gon instead of these names. Types of polygons. Regular or irregular. A regular polygon has all angles equal and all sides equal, otherwise it is irregular. Simple or complex. A simple polygon has only one boundary, and it doesn't cross over itself. A complex polygon intersects itself. Many rules about polygons don't work when it is complex. More examples: irregular hexagon, concave octagon, complex polygon, a star polygon. Equiangular or equilateral. Equiangular, all angles are equal. Equilateral, all sides are the same length. Polygons may be convex or concave. A polygon is convex if no diagonal is in exterior of the polygon. A polygon is concave if at least one diagonal is in the exterior of the polygon. Convex, a straight line drawn through a convex polygon crosses at most two sides. Every interior angle is less than 180 degrees. Concave, you can draw at least one straight line through a concave polygon that crosses more than two sides. At least one interior angle is more than 180 degrees. Special polygons. Special quadrilaterals, square, rhombus, parallelogram, rectangle, and the trapezoid. Special triangles, right, equilateral, isosceles, scalene, acute, obtuse. Some of the measures of the interior angles of a polygon. Interior angles of polygons. An interior angle is an angle inside a shape. Another example. Triangles. The interior angles of a triangle add up to 180 degrees. Let's try a triangle. It works for this triangle. Now tilt a line by 10 degrees, it still works. One angle went up by 10 degrees, and the other went down by 10 degrees. Quadrilaterals, squares, etc. A quadrilateral has four straight sides. Let's try a square. 90 degrees plus 90 degrees plus 90 degrees plus 90 degrees equals 360 degrees. A square adds up to 360 degrees. Now tilt a line by 10 degrees, 80 degrees plus 100 degrees plus 90 degrees plus 90 degrees equals 360 degrees. It still adds up to 360 degrees. The interior angles of a quadrilateral add up to 360 degrees. Because there are two triangles in a square, the interior angles in a triangle add up to 180 degrees, and for the square they add up to 360 degrees, because the square can be made from two triangles. Pentagon. A pentagon has 5 sides, and can be made from 3 triangles, so you know what, its interior angles add up to 3 times 180 degrees equals 540 degrees, and when it is regular, all angles the same, then each angle is 540 degrees / 5 equals 108 degrees. Exercise. Make sure each triangle here adds up to 180 degrees, and check that the pentagon's interior angles add up to 540 degrees. The interior angles of a pentagon add up to 540 degrees. The general rule. Each time we add a side, triangle to quadrilateral, quadrilateral to pentagon, etc., we add another 180 degrees to the total. If it is a regular polygon, all sides are equal, all angles are equal. Shape. Sides. Sum of interior angles. Shape. Each angle. Triangle. 3 sides. Sum of interior angles 180 degrees. Regular triangle. Each angle measures 60 degrees. Quadrilateral. 4 sides. Sum of interior angles 360 degrees. Regular quadrilateral. Each angle measures 90 degrees. Pentagon. 5 sides. Sum of interior angles 540 degrees. Regular pentagon. Each angle measures 108 degrees. Hexagon. 6 sides. Sum of interior angles 720 degrees. Regular hexagon. Each angle measures 120 degrees. Heptagon. Or septagon. 7 sides. Sum of interior angles 900 degrees. Regular heptagon. Each angle measures 128.57 degrees. Octagon. 8 sides. Sum of interior angles 1080 degrees. Regular octagon. Each angle measures 135 degrees. Nonagon. 9 sides. Sum of interior angles 1260 degrees. Regular nonagon. Each angle measures 140 degrees. Any polygon. N sides. N-2, times 180 degrees. Regular n-gon. N-2, times 180 degrees divided by n. So the general rule is, sum of interior angles equals, n-2, times 180 degrees. Each angle, of a regular polygon, equals, n-2, times 180 degrees divided by n. Perhaps an example will help. Example, what about a regular decagon, 10 sides? Sum of interior angles equals, n-2, times 180 degrees equals, 10-2, times 180 degrees equals 8 times 180 degrees equals 1440 degrees. And for a regular decagon, each interior angle equals 1440 degrees divided by 10 equals 144 degrees. Note, interior angles are sometimes called internal angles. Sum of the measures of the exterior angles of a polygon. Exterior angle. The exterior angle is the angle between any side of a shape, and a line extended from the next side. Another example, when we add up the interior angle and exterior angle we get a straight line 180 degrees. The end. Thank you. Please subscribe and hit the bell button.